Good morning. Well, it's definitely morning for me anyway. We are going to work on page 33 from the Unit 3 packet that you worked on yesterday. And by the way, very, very nice job yesterday on your exit tickets and your participation on the video. So off to a really great start for the new year. If you haven't gotten to the exit ticket, please go do that. I was looking at them yesterday, and I will look at them again today. So what I did for today is I had to do this graph for you because it would take too long in the video. So we're just going to skim over this first example, and then we'll do another one together on the other page. But I'm going to read to you what is happening in this graph in order for us to be able to answer the question. So Jared's basketball team stood at various distances from the basketball goal and counted the number of baskets they were able to make in 30 seconds. So that's fun. The distance each person stood from the goal and the number of baskets made is shown in the table. So what's happening is this is data that somebody collected on the teammates. And so when you write it in this form, it's hard to see if there's a trend. It doesn't really show as easily as if we were to put it into a graph. So what they did is they did graph this, and you can see a couple things going on. So what type of association do you see in the scatter plot? List any other observations in the space below. So my dog's, hang on a second. Oh my goodness, I'm sorry. I had to pause the video because my dog was whining in the back, and I was trying to figure out, I thought he wanted to cuddle or something. He had to go to the bathroom, the poor thing. He usually doesn't wake up until I leave. I'm sorry. So I'm back. I usually don't have any distractions at this time of the day. It's talking about in question 1, we're looking at this graph that I have taken from the data table and plotted points, which we're going to do together in a second. And it's asking, what type of association do you see in the scatter plot? Well, I can see they start up high here, and as you go to the right, they get lower here. So this is a negative association. And list any other observations. Well, you can see there's like 2 groups, right? So there's some space in between. And I can also see that this piece of data right here is kind of not with the rest of them, right? So use the scatter plot to label each statement as true or false. As the distance from the goal increases, so this is distance from the goal, Mrs. Raymond. I think it's really weird they call it distance from the goal. And this is the number of baskets. This is why you must label. Okay. As the distance from the goal increases, so you go this way, the number of baskets made decreases. So at 16, it's higher than when the distance from the goal is 28. So this is true. As the distance from the goal decreases, the number of baskets made increases. So I guess as you go this way, does it go up? So if you're closer, if they were closer, were they shooting more baskets? Yes. As one goes up, the other one goes up. As one goes down, the other one goes down. So up, down, down, up. And so it's true, right? As the distance from the goal decreases, the number of baskets made decreases. Well, how can you say that this is true and then also say that this is true? As the distance decreases, the baskets increase, right? It kind of makes sense, right? The closer you are, the easier it is to make more baskets. So that kind of goes along with some common sense also. So what we're doing is talking about a couple key components of a scatter plot in this little section. And this piece right here, we talked about that one that was a little separate. That's called an outlier, a point that does not fit the overall pattern or trend of a scatter plot is known as an outlier. Who was the outlier in the scatter plot above? So this point right here is the one that's not with either 2 of these groups, which we are going to call clusters. And this was the point 14, 4, which is Jared. So Jared is the outlier. I'm not writing everything I would normally write if we had a bunch of time, and also I'll just verbally tell you that it's because the number of baskets he made was much lower than the rest of his team. He doesn't fit with the rest of the pattern, right? He kind of stands out. Most of you are familiar with that word and comfortable with that word. Let me focus this a little bit more. Okay, and then another word that we use to describe some things that happen in scatter plots is this clustering. See how there's like these two little groups? The groups are called clusters. So clustering occurs in a scatter plot when there are distinct or separate groups of points. Why do you think clustering occurred in the scatter plot above? Well, it seems that you had like a group of kids that were shooting closer to the basket, and then you had another group of kids that were shooting farther away from the basket. And we're not going to write that down because we need to save some time. So what we're going to do today in the video lesson is mildly approach constructing the scatter plot. So you go out, you collect data on whatever it is that you're interested in. You're looking at the data and you're like thinking, all right, this is kind of hard to analyze. Maybe you can answer if it's a function or not, but it's tough to analyze unless you put it in a picture form, in this case, a scatter plot on a graph. So I have started by plotting a few of the points here, and I'm going to show you how to plot the rest of them. So this story is talking about the population of 10 cities and the number of elementary schools it has shown in the table below. So you have your city, the population, and the number of elementary schools. Make a scatter plot. So what I did, and I think this is really important for you to also do, is as I plotted the points, I checked off that it was complete. It helps me stay organized. And the other piece of why I'm doing this one with you is it is labeled and the scale is done for you. And for 8th grade math, they don't really press so much you having to construct and make your own. But we will practice it because it is a skill that you'll need in other classes. But we'll practice that in class. It's a little easier to talk about together. So for this one, we're just going to use the pre-made scale on the graph. So I have already done these. So we are going to move to plotting Weatherford. And the population is 25,000, and the number of elementary schools here, they have 12. So what's strange is the numbers that you use. You're not maybe perhaps used to this. So 25,000 is actually, see, population is where you go on the x-axis. So you have to find 25,000. I'm looking at the scale. It goes 10 to 30. So in between this must be 20, right? So if we're doing 25, this would be about where 25 is. And we're going up to 12. So which would be here. And then I'm going to check it off. Prosper has 13,007 elementary schools in it. So 13,000. So this would be 10, 20, 30. So between 10 and 20, I'm going to say 13 is about here. And I'm going to go up to 7. I actually think this is kind of fun. Okay. Glens Falls, 20,000 for the population and 20 elementary schools. 20,000 and 20 elementary schools. Woo-wee! It's a lot for that, right? And then Dalton is 85,000 for the population and 21 elementary schools. So they have this almost the same number of elementary schools and a very big difference in their population, right? So 85,000, so 70, 80, 90. So you're going to be between 80 and 90 for your 85,000. Take that, follow it up to 21. And plot your point, check it off. Describe any association between the variables. What conclusions can we make? Well, you can see that as the population increases, it seems that there'd be more elementary schools, right? So as the city's population increases, there are more schools present. So this is a positive linear association. The greater the population, the greater the number of elementary schools. One goes up, the other one goes up. If one goes down, the other one goes down. The greater the population, the greater the number of elementary schools. So are there any outliers in this data? Is there any point here that doesn't really seem to fit with the rest of the points? I think there's definitely one. I think this one right here stands out, right? It doesn't fit with the rest of the pattern here. It's got a pretty low population, a pretty high amount of elementary schools for that. So Glens Falls is your outlier. That's kind of near where I used to work, was the school district over. And is there any clustering in the data? No, I mean, there would be if you had like a big gap between these two and there's like a cluster here and a cluster here, but there isn't. There's points all the way throughout here. So there actually is no clustering. And the reason I'm not writing out the explanations is because we are going to be running out of time. So this is generally the idea of what we're going to be doing in class together. And this isn't such a jump from what we've done in the past. We've constructed scales, we've plotted points. I think the difference is the points, the numbers in the points are different. And we are talking about looking at trends, like overall, what does it look like? You know, it's not super exact. We'll get into that a little bit later. So for right now, just having an idea of how to plot the points is great. So I'm going to have you for today work on this question here for class together. So try this out, plot the points, the scale's already made for you, and answer the question to the best of your ability and see how you feel about it. And I'll check this and then we'll go over this together in class. So I hope you have a really great day and I will see you soon.